to boldly go where no one has gone before. One problem. We have to develop the technologies and build the vehicles to get us there. Luckily, one of the main missions of the International Space Station program is to develop and demonstrate technology capabilities that will enable future exploration missions beyond low Earth orbit. The ISS is a critical testbed for verifying a variety of technologies, systems, and materials that will enable future long-duration exploration missions to infinity and beyond. Hi, I'm NASA astronaut Tracy Dyson. Welcome to StationLIFE.
Houston on 2 for velocity calculation, assembly, steps 45 and 46. We're moving on to step 5.
Go right now for that activity.
Copy, thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
Today we're going to talk about the ISS as a platform to test and demonstrate new technologies that will enable us to go on future exploration missions beyond low Earth orbit to infinity and beyond. No kidding! We're talking about potential missions to asteroids and even Mars. Right now, Scott Kelly's on the ISS for the one-year mission. NASA scientists are hoping to learn more about the effects of prolonged spaceflight on the human body. Typically, our stay aboard the International Space Station is about 6 months long, and right now, a mission to Mars would take 30 months. We need to know how to stay healthy for long periods of time if we're going to take on a journey like this, and there's only one place to learn how. You guessed it, the International Space Station. There's a lot of interest right now in the journey to Mars. Great strides are taking place in the Orion program and the SLS rocket, which we hope will take us to Mars someday. Check out this video from NASA's Associate Administrator, Bill Gerstenmaier, as he discusses the challenges we face on a journey to Mars and the lessons we've learned from the International Space Station.
If the future of mankind means living on another planet, our close neighbour, Mars, has got to be a good starting point.
It's a huge challenge for us, but it's not so overwhelming that we couldn't get there and then still return.
This is no pipe dream. The engines, rocket bodies and abort systems to make this journey to Mars and back are being built and tested by NASA right now. And here is a preview of the Space Launch System, or SLS, scheduled for its first test flight in 2017. It will be the most powerful rocket in history, designed like the shuttle to take huge payloads into orbit.
It's about as tall as the Statue of Liberty, and it can launch 130 metric tons.
The SLS is designed to carry a crew capsule and up to 4 astronauts. And NASA's plans for testing the capsule, to be called Orion, involve capturing an asteroid and having the astronauts do a spacewalk to collect samples before returning to Earth.
This is kind of our proving ground to build those next series of concepts and techniques and hardware that will be needed to go to Mars.
Much of what happens on the space station today lays the groundwork for a future when NASA is ready to transport us to other worlds. The human mission to Mars will eventually require another spaceship built on the same scale and in the same way as Space Station.
We've learned from Station we can build over multiple years, decades, and actually assemble a fairly large structure.
It will be built from parts flown into orbit by the new SLS. Once complete, and with Orion attached as the Mars lander, the new spaceship will embark on the 6-month voyage to the Red Planet.
When we're ready to break that tie with the home planet and become independent of the Earth, we better have learned all those lessons from Space Station. This is not the beginning of the end. This is really the beginning of a new bright horizon.
And an adjustable on the wire tie. I've got another adjustable on the front.
V rocket engine. Heat shield testing. Ground systems development and operations. Rocket core. Solid rocket booster construction. Solid rocket booster test.
Commit the motor. Motor is committed.
Pad flush is on.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
NASA is suiting up, getting ready to send humans on a journey to Mars. To do it right, the spacesuit must be tough, shielding the astronaut from dust, heat, cold, radiation. It must be sophisticated, providing air, power, communications. The spacesuit must be flexible, allowing the human body the freedom to explore as only humans can. We have 50 years of experience suiting up, sending humans out of the spacecraft in what NASA calls extravehicular activity. We have walked in space and proved there was a universe of possibilities that awaited us. We have shown that with a spacesuit, human hands can repair, save, and build things in space. With spacesuits, we even explored the moon, opening new frontiers and expanding our knowledge. And as NASA prepares to travel further into the solar system, a new generation of spacesuits will help us make future discoveries. Suit up with us and explore this NASA website celebrating 50 years of extravehicular activity.
Welcome back. We already mentioned how the ISS is a great place to learn how to live in space. One of the basic things we're figuring out is how to grow food in space. A series of experiments called Veggie is helping us to learn how to grow food in space right now. The farther and longer humans go away from Earth, the greater the need will be to grow plants for food, atmosphere revitalization, and psychological benefit. Check out this video about growing lettuce on the International Space Station. It's spring, and all around the Northern Hemisphere, gardeners are planting seeds, tilling soil, and watering crops. Imagine a gardener's surprise, however, if the water from the hose, instead of hitting the soil and sinking in, floated up to the sky.
or if the soil itself rose up from the ground and flooded the garden. That's exactly the kind of dilemma astronauts aboard the International Space Station have faced for years. Without gravity, how do you make your garden grow? The situation is even more confusing for plants. In a weightless environment, up and down have no meaning, so roots grow in odd, chaotic directions. Shoots that emerge from the soil in search of sun find instead a cold metallic lamp that never rises or sets. And needless to say, it never rains inside the space station. In 2014, the SpaceX Falcon rocket, carrying the Dragon cargo spacecraft, blasted off from Cape Canaveral in Florida with a possible solution to these problems. We call it Veggie. It's a plant growth chamber designed to make gardens thrive in weightlessness. Joya Massa, who leads the Veggie science team, has been working on the project for years. Veggie's heritage traces back decades to experiments with plants on board the Russian space station Mir and NASA's space shuttles. In all that time, NASA astronauts have never tasted homegrown food in space, but that could soon change. Our first crop will be a variety of lettuce called outrageous. It is delicious. Veggie solves the problems of weightlessness using plant pillows. Basically, these are bags of, quote, space dirt and slow-release fertilizer. Wicks, inserted into the bags, draw water into the soil where it can't float away. In addition to guiding water, the wicks act as kind of a gardening stake. The wicks are where we glue the seeds. We have to be very careful to orient the seeds so that the roots grow down into the soil and the shoots pop out of the bag. When the shoots emerge, they find an array of LEDs shining overhead, providing light for photosynthesis and a sense of direction to keep the shoots moving up. The bellows-like walls of the chamber allow it to expand to make room for the growing crop. Pictures of Veggie often show the chamber flooded with a mixture of red and blue light. That's the color of light plants use most for photosynthesis. We're just giving them what they want. Under a purplish light, plants appear gray and unappetizing. Who wants to look at that? Astronaut gardeners can switch on green LEDs as well. Adding that color to the red-blue mix produces white light and displays the garden to better effect. The appearance of the garden is important because gardening has psychological as well as nutritional benefits. Compared to Earth, spaceships are a relatively lifeless environment, cold, metallic, and sterile. Plants allow astronauts to form a connection to living things. There could be a huge psychological benefit. Chalking up another success for commercial spaceflight, the Dragon capsule delivered Veggie to the space station on Sunday, April 20th, 2014. The first crop of outrageous was harvested in late May of 2014, but astronauts weren't allowed to taste test. First, we had to bring the lettuce home for analysis. Thankfully, it turned out fine. No bacteria or contaminations were found. The latest Veggie experiment on the ISS will be harvested in August of 2015 to be half eaten by the crew and half frozen for further analysis. Salad, anyone?
You may not know this, but the International Space Station was assembled by partners from 15 countries over a 15-year period, using huge robotic arms to do the construction work that was too large and massive for astronauts to handle on their own. For future exploration, we plan to use these same large robotic arms to do a lot of the heavy lifting. But we also have humanoid-like robots to assist astronauts in doing the smaller, fundamental space exploration tasks. Let's hear from our very own robotics genius, Dr. Rob Ambrose from the Johnson Space Center, as he explains the significant role that robotics will play in future exploration plans.
So in this lab, we've got a number of robotic systems that you see behind me. These are the Robonauts. In fact, the second generation, Robonaut 2, as we refer to it. These robots are some of the first caretakers that NASA has developed. We've got one on space station right now, in fact. It's got legs like the one over my right shoulder. It's able to move around on the space station and get to wherever it needs to be to do some work. It's got pretty amazing hands, not as good as human hands, but good enough that it can handle a tool that's built for a human. And what that allows is that the robot is able to work with the same interfaces and equipment that are built for the people. If I were to ask space station, why don't you start all over again and put in a bunch of rails and other things that would allow me to use a simpler robot, they'll say, go away. You know, it's already built and it's built for people, and we're not going to go customize everything just for a robot. And that's reasonable. If you could get the world to adapt to your design, you know, that's great, because then you can use a simpler robotic system, and it's good work if you can get it. But most of the world's already built, and it's built for us as humans. So we're kind of turning the corner where we now have this new opportunity to have a robot that can work in a world built for people. Now it's harder, but the technology is now there. A robot that can handle a tool built for the human hand, a robot that can climb or even walk into a location that was developed for a human to get to. We're now able to do that. And so it allows us to just accept the human as the standard and not have to build extra equipment just for the robots. The most sophisticated jobs, well, we're not there yet. Human judgment is you know, far ahead of where we are with robots. You know, they'll just stare at something and it just looks shiny to a robot. Humans have the judgment, and that's what we really want to use with our astronauts in space. A robot can do things like, here, hold this for 4 hours. You know, crummy job for a person. Turns out robots like to stand still. They're really good at it. So if you have a job that's crummy for a person, let's have a robot do that task, and then we'll save the astronauts time, which is very valuable for the ones that really need judgment and, you know, scientific exploration.
As you can see, for the future of human exploration, it's all about the technology. So, to get the big picture of advancing technologies and how it all fits together, let's hear from the Chief Technologist from the Johnson Space Center, Douglas Terrier. Awesome.
I'd like to tell you about how we're using the International Space Station as a critical element in our technology development strategy to develop the capabilities that we need to send humans into deep space and eventually to Mars. So we have a comprehensive technology development strategy at NASA where we work with the exploration architecture teams to understand exactly what the critical capabilities are that we need for humans to survive in deep space for the extended missions that we anticipate to go to the moon region and on to Mars. Using our research and technology money, we've demonstrated those capabilities on the ground, and we're now ready to demonstrate them in a microgravity environment. So the International Space Station provides the ideal platform for doing that. Today we have an R2 robot, humanoid robot on the International Space Station, and we're using that as a way to prove out a lot of the capabilities and automation that we need to demonstrate for eventual operation of that system in deep space exploration missions.
In this episode of StationLIFE, we learned how the International Space Station is being used as a test bed for new exploration technologies so we can go beyond low Earth orbit. We're refining how to grow food in space. We're learning more about the effects of long-duration spaceflight with the current one-year mission and astronaut Scott Kelly. We're testing laser communication systems, and understanding what's required in keeping our life support systems functioning reliably. You better believe that the technologies developed for space exploration often find applications right here on Earth. NASA spin-offs provide solutions for challenges in the fields of health and medicine, industrial production, communications, transportation, consumer goods, public safety, and much, much more. But hey, don't just take my word for it.
Imagine doctors giving an ultrasound to patients hundreds of miles away, on Earth or in space. Imagine tiny, life-saving heart pumps created with rocket engine technology. Imagine robot-assisted surgery. NASA did, while creating the advanced technologies needed for space missions. NASA has developed medical innovations that can be applied to life right here on Earth. These technologies give first responders fast and reliable medical tools that help save lives. They also enhance preventive care. The thermometer pills, originally made for astronauts, which are now used to make sure athletes, firefighters, and soldiers don't overheat in the field. NASA's innovations have even resulted in nutrition plans that help people stay healthy and lose weight. Spin-offs like these are just a few examples of how NASA technology turns science fiction into science fact. There's more space in your life than you think.
Thanks, Captain. As you can see, we're well on our way to going where no human has gone before. Be sure to stay in touch and follow us on Facebook and Twitter for the latest research news. And don't forget to download our Kickin' app on your mobile device. Until next time, we're working off the Earth, for the Earth. To infinity and beyond! Can't believe you guys are making me do this.